I have here in front of me a typical motherboard. Now if you look, it's kind of hard to see from where you're at right there, but that's a CPU right there. So every computer needs a CPU and every CPU needs a motherboard. There are 3 nerds out there right now who are coming up with exceptions. Ignore them. So what we need to do is when we're building a system is we need to put a CPU into the motherboard. Fairly straightforward. Now we got some choices here. If we wanted to, and if you went back a bazillion years ago, you'd solder the CPU to the motherboard. In fact, on a lot of mobile devices, they still do that. But what we like is upgradability and compatibility with different motherboards and different CPUs. So what we're going to be talking about right now is what we call CPU packages and CPU sockets. Really, I want to concentrate on the sockets. The whole idea behind CPU sockets is that I can buy a motherboard and that I can remove a CPU and come up with a newer CPU, an upgraded CPU down the line, and I can go ahead and take advantage of that. Now the A+ exam covers a really broad cross-section of AMD and Intel CPU sockets, and we're going to go through every single one of them. Now when we talk about a socket, we tend to talk about the number of pins on the socket, its physical size, thermal characteristics, all kinds of stuff. But for the A+, we really just need to go over a few basic ideas, and I'm going to hit all of them right now. Now, before we go into too much detail here, I want to talk about some of the physical aspects of packages. CPUs have come in all kinds of different shapes and sizes over the years, but with the A+ and in today's world, we can break down pretty much every CPU socket into one of 2 groups, either LGA or PGA. So let's take a look at both of these. Starting off right here, what I have is, this is an AMD CPU, and we're going to cover this one in detail. But for right now, what I want you to do is just take a look at this. This is a PGA or pin grid array. The reason we call it this, oh, by the way, this socket that it's sitting on is a ZIF, zero insertion force socket. So I'm going to pull this up, and I want you to look right here. If you look very, very carefully, you'll see that there are zillions, hundreds of little tiny pins on there. And yes, if you snap off a pin, you've pretty much wiped out the CPU. So this is one example of a PGA. I'm going to get that guy back in there. It's always tricky. Then we're going to drop it back down. Ta-da, that's PGA. Now the other main type of CPU that you're going to be seeing out there is LGA. So what I have here in front of me is an Intel LGA type socket. So it's still called a zero insertion force, but it's got a pressure plate on the top. Now, but what I want you to take a look at is here on the bottom. LGA stands for Land Grid Array, so the pins, which are actually little tiny springs, are on the socket itself. The CPU just has little pads, or LANs as we call it. So people like these because it's harder to damage the CPU by snapping off one of these little pins. See if we can get this guy back in here. Fantastic. So you have to memorize a number of different sockets for the A+. Keep in mind one thing. All the AMD sockets you're going to learn are all pin grid array, and all the Intel sockets you're about to learn are land grid array. So let's march through every socket you need to learn for the CompTIA A+. The first Intel socket I'd like to talk about is LGA 775. LGA for land grid array and 775 for the actual number of pins, or technically LANs, on each CPU. Socket 775 is a great place to start because it's the first mainstream CPU and socket to use these LGA. It ran with DDR2 and it had a long, long life. It started way back with the Pentium 4s and lasted all the way through to the Core 2s. Now, socket LGA 775 did a great job, but it was replaced by 2 different sockets, 1156 and 1366. Let's look at both of these. First of all, here we've got LGA 1156. This was more for the mainstream systems, and it also was the first socket that supported a built-in North bridge. And along with that, it had DDR3 support. So the first time we began to see Core i3s, i5s, and i7s was in the 1156. For the higher end systems, we had Intel socket LGA 1366. Now, this had a built-in memory controller so it could talk to RAM, although it still kind of had a North bridge for PCIe bus support. It could support lots and lots of DDR3, and it was pretty much used exclusively on the Core i7. Over time, 1156 and 1366 were also replaced. The 1156 was replaced with socket LGA 1155. This was more the mainstream, and CPUs using these sockets were the first to have full support of onboard graphics. And we'd see again Core i3, i5s, and i7s. The Intel socket LGA 2011 replaced the 1366 on the higher end system. It started out with DDR3, but later went to DDR4. Interestingly, these sockets supported the first systems to stop supporting PCI. It only supported PCI Express. And yep, once again, Core i3, i5, and i7. Now the last Intel socket I want to talk about is Intel socket 1150. This is a mainstream type socket. It interestingly supports multiple CPUs. It started off with DDR3 and supported DDR4 and supports an outrageous number of PCIe devices. Now, if you think that's a lot of sockets, well, you ain't seen nothing. First of all, we haven't even talked about AMD yet. Secondly, the A+ skips a lot of different types of really important sockets. For example, a lot of mobile systems have sockets. A lot of big, super high-end Intel Xeons have server sockets. And luckily for us, those are not covered on the A+. Now, when you think about this stuff, you might be tempted to go, okay, I understand the idea of sockets because a new CPU comes out, then it's going to have a new socket. That new CPU is going to have new features. It should have a new socket. Wrong. What's really taking place is something called microarchitectures. Intel and AMD are always thinking way into the future. They're coming up with what's going to happen in 3 to 5 years, sometimes even longer than that, in terms of new technologies, in terms of speed improvements, reducing the transistor sizes so you can put more transistors on a single CPU. And they come up with a basic, I'm going to call it a recipe, a pattern for a certain set of technologies that they're going to fix into time and place, and they're going to go ahead and start designing and coming up with a new CPU for this new stuff. And these are called generically microarchitectures. So a microarchitecture is a core piece of what we want the next version of CPU to do. And they actually will have code names that will, when they're talking about these CPUs for in the future. For example, you'd have code names, Intel uses names like Ivy Bridge and Haswell and Skylake. And these code names for microarchitectures do eventually become real CPUs, but not just one CPU. You can take one microarchitecture and cut down a few of the features and use it for a lower end system. And you can have a few extra things and have it for mainstream. Or you can add extra bells and whistles and it could be a server level CPU. So in general, and there's lots of exceptions to this rule, but in general, when a new microarchitecture comes along, a new socket is developed. And let me stress that one more time. There are plenty of exceptions to that very, very basic rule. Okay, so we've gone through the Intel sockets. Let's go ahead now and dive into the AMD sockets. AMD breaks all of their sockets into two groups, which I'm going to call the AM group and the FM group. So let's start off with their more mainstream product, the AM type sockets. The AMD AM sockets are kind of unique, so I need you to watch very, very carefully as we go through each one because the differences are subtle. So let's start with the socket AM2. Before socket AM2 came along, AMD sockets had all kinds of different numbers, and it would be socket 939 and 940 and all these different crazy numbers. Socket AM2 is a good place to start with AMD because it was the first time they started dumping the pin numbers. So I'm going to have to tell you the pins. Now, the socket AM2 had 940 pins, and it ran primarily on a lot of late generation Athlon 64 processors. It had hyper-transport capability and also supported DDR2. Now watch the changeover as we look at the next one. You ready? This is socket AM3. Not much of a difference, huh? Well, socket AM3 had 941 pins. It supported Athlon 2s, Phenom 2s, and also supported DDR3s. The next click up is socket AM3 Plus. AM3 Plus supported Athlon 2s, Phenom 2s, DDR3. You'll notice it has 942 pins. Look carefully, you can tell. The big difference here was nothing more than power and speed improvements. Now I'm being a little bit unfair when I say AM is purely a mainstream type socket. The big difference about AM and what we are about to learn about the FM sockets is that AMD separates sockets based on graphics capability. Generally what we have is what we call, well, AMD's term is APUs. Their CPUs that have graphics capability are known as accelerated processing units, or APUs. Now someone from AMD, if they heard me say this, would probably get really crabby because they'd go, no, our APUs have lots of other features, and they do, but let's face it, the big difference is the graphics. So if you're going to get an AMD CPU with graphics capability, in general, you're going to be using an FM type socket. Let's run through those. The first type of AMD socket to support AMD APUs was known as the FM1. So here's an FM1. So the next one is the FM2. The FM2 had 904 pins. It had some power and speed improvements, and really that was just about it. Third is the FM2 Plus. With a whopping 906 pins, it was even more incremental improvements to the FM2, in particular, more than anything else, substantially more PCI Express support. Okay, well, I have now officially covered every type of CPU socket that you're going to see on the A+ exam. But just as an aside, this is not on the exam, but understand that CPUs exist everywhere. Every smartphone, every tablet, all of these different types of devices have CPUs in them, and a lot of them have sockets too. So while it is important for A+, which is a very Wintel type organization, thinking about CPUs in terms of Intel and AMD, remember, there's lots more out there. Make sure to memorize all the different types of sockets shown in this episode.